Okay, fam, let's get this done. Remember, polar and non-polar covalent bonds are both made up of nonmetals. How do you tell them apart? Which type of bond, non-polar, moderately polar, blah, 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 will form between each of the following pairs of atoms? Use the electronegativity values for each element and subtract the smaller number from the bigger number. Find that number on the chart provided to determine the type of bond that forms. So I don't have that chart you guys may have, and either way, values kind of just range from book to book, but I do know how to do it in a different way that doesn't involve any math. So from this side, which element do you guys think has more electronegativity? Oxygen or potassium? You guessed oxygen, you're right. So the more electronegative elements are more to the right and up. So for example, oxygen, it's more to the right on the periodic table and higher up than potassium is, right? So the closer you are to like fluorine, basically, if you want to use him as the like a landmark, the closer you are to fluorine, the more electronegative you are. So for example, strontium is less electronegative than nitrogen. Carbon is more electronegative than cobalt. Between fluorine and oxygen, fluorine is more electronegative than oxygen. So you feel me? Pretty easy, right? So the more to the right and the higher up, closer to fluorine, basically more electronegative in that direction. The further you are from that direction, the less electronegative. So we got that down, right? Not too hard. Next, I like to use this little cheat sheet. Go ahead and write this down. Fluorine is greater than oxygen, is greater than nitrogen, is greater than carbon, estimated right here. Not equals, this is an estimation, okay? Hydrogen right there. Hydrogen is at 2.1 electronegativity, 2.5. Like I said, these values range from book to book, resource to resource. It's not that off. Someone might write, I don't know, 3.9 instead of writing 4.0. You know what I mean? So just write that cheat sheet down. So right here, look over here really quick. I'm going to do it in pink. Look at fluorine. Oops, pen. Fluorine is greater than O. O is greater than nitrogen. Nitrogen is greater than carbon. And carbon is greater than hydrogen right here. So we got fluorine, oxygen, nitrogen, carbon, hydrogen, sorry. A lot of hydrogens. So with that being said, this is the little cheat sheet I use right here. So go ahead and write that down so you kind of have a pinpoint of their values if you need some kind of number. Now, moving forward without using numbers, let's establish first which ones are covalent, meaning non-metals, two non-metals or more, two non-metals. And if you remember from the previous video, these guys, non-metal, non-metals, 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 non-metals. So anything that's blue is pretty much non-metals, everything else is a metal. Cool? I just scrabbled really quick. So let's get into it. So I'm going to write a C, I'm going to abbreviate to save time. So chlorine and chlorine, covalent. KNO, ionic, covalent, covalent, covalent. Barium and chlorine, ionic, covalent, covalent, ionic, ionic. Because we have a non-metal with metal, metal with non-metal, non-metal with metal. Oh, sorry, these two are both non-metals, that's why they're covalent. So just remember, these are not carbons and iodine, these are, covalent and ionic. Next, we established that. Now let's establish our polarity. First things first, when you have two elements that are the same, so in this case we got Cl and Cl, that's pretty electronegative, right? Because it's right next to fluorine. But there's two of them. This is like tug of war in a way. This is all this is. Polarity, non-polar, moderately polar, polar, very polar, or ionic. It's just a tug of war game. So two of these guys would be actually, you know what? I'm going to abbreviate again. They would be non-polar covalent. So we add the word covalent or ionic at the end of it. So this would be non-polar covalent, because two of them that look the same are pulling on each other. It would be like a tug of war with two fat kids, right? No one's going to move. Now, if you had a skinny kid and a fat kid, obviously the fat kid's going to pull them in. That's how I think of it. No, it's not politically correct, but whatever. Now let's go for KO. We said it's ionic, so it's an ionic, like right here, ionic bond. So this one's just ionic. This is covalent, so C and O. Let's check it out. We got C, and we got O. Who's more electronegative? O. So O is pulling him this way because he's more. Get it? So this one would be polar. Polar covalent. H and I. What do you guys think? I'm already going to tell you polar, but let's find out. We got iodine, way on the right. We got hydrogen. Who's going to pull who more? Right? One is pulling on the other. So this one is polar. What's the next one? H and O. Ooh, let's see. This one would be polar here. I'll just give you the answers right away. Ionic. This would be non-polar. This would be polar, polar, ionic. And I just want to reiterate with my little cheat sheet earlier. F is greater than O, greater than N, greater than C, estimator here, H. Our values are 4.0, 3.5, 3.0, 2.5, and then 2.1. Now, you could do it the mathematical way like they want you, right? Like let's say they had fluorine and oxygen. So this and O, 4.0, 3.5. You would do 4.0 minus 3.5, which equals, what do you think? Exactly, just 0.5. So there is a little bit of a mathematical rule if you're going to do it the math way. My way, I just do it based on how I see it. So I identify which ones are covalent, ionic, and then I just see who's the closest to the right of the periodic table and up. Closest to fluorine, that's my landmark. Now, the displacement, triangle just means displacement, or the difference in electronegativity, I'm just abbreviating, so the difference in electronegativity, if it's 0.5 or greater, it's usually polar. So if it's 0.5, this one would be polar in this situation right here, right? F and O, if we did, instead of it's these ones, it's just F and O. So 4.0 minus 3.5 would be 0.5. So if it is greater at 0.5 or more, it is polar, okay? If the difference in electronegativity is less than 0.4, so 0, I'll put it 0.5, 0.4. If it's less, then it is non-polar. You feel me? So this is the mathematical way of doing it, how they want you to do it. So you look on your worksheet, which one has a number, subtract it. If the answer is 0.5 and higher, it's polar. If it's 0.4 and lower, non-polar. Pretty simple, right? So some other ones that are good to remember, let me just get rid of this. That's pretty much how you do it the mathematical way, the way that they want you to do it. I just do everything based on how I see it, because chemistry is really not that hard. People just make it hard, more harder than what it is. These are some other ones that are good to remember. Carbon, nitrogen, which we stated up there, 2.0, 2.5, 3.0, 3.5, and 4.0. So let's say we had, I don't know, B and F. Right? This was our situation, kind of like these. First things first, let's identify, is this covalent or ionic? Where's B located? B. Okay, boron is located in the metal area. F is located in non-metal, so this one automatically is ionic. But let's try to figure out the polarity mathematically. B is 2.0, F is 4.0. What is 4.0? Bigger number first, always. 2.0, what does that equal? Yes, 2.0. Is 2.0 less than 0.4 or greater than 0.4? Greater, so this one would be polar. So that's how you do it the mathematical way. You get the number. I just like to remember these always. These ones are my secondary, but most of these go back into this. As long as you know F is greater than O, greater than N, greater than C, greater than H. Or you could just do this. F is bigger than him, bigger than him, bigger than him, because he's more to the right and higher. That's how I just do it. That'll help you out. And obviously you guys know how to tell the difference between covalent and ionic, and now you guys know how to tell polar and nonpolar just based on looking on the periodic table, and now you also have learned how to do it the mathematical way. Have a good day, guys.